The Mediterranean Sea, cradle of empires and birthplace of civilizations, once completely disappeared. It did not just recede, it vanished, leaving behind a sun-scorched abyss nearly 2 miles deep. Imagine standing on the coast of Italy and looking not at a blue sea, but at a shimmering, salt-encrusted desert floor. This desolate landscape plunged thousands of feet below the level of the world's oceans. This wasn't a fantasy, it was a geological reality. The Mediterranean has always existed on a knife's edge. It is a natural evaporation basin, a place where the sun's heat removes far more water than rivers can replace. Every day, trillions of gallons of water are lost to the sky. Mighty rivers like the Nile, the Rhone, and the Po pour fresh water into the basin. But their combined flow is not enough to counteract the relentless evaporation. The sea's very existence depends on a single narrow lifeline to the Atlantic Ocean, the Strait of Gibraltar. Deep beneath the Earth's surface, colossal forces were at work. The African tectonic plate, a continent-sized slab of crust, was grinding its way north. It relentlessly pushed into the Eurasian plate with unimaginable power. Around 6 million years ago, this slow-motion collision reached a critical point. The pressure buckled the Earth's crust at the gateway to the Atlantic. The seafloor at the Strait of Gibraltar began to rise, creating a mountain range where there was once a channel. The gate was closing. Once that lifeline was severed, the Mediterranean's fate was sealed. The sun, now an unopposed engine of desiccation, continued its work. With no Atlantic water flowing in, the sea level began to plummet at a staggering rate. Scientists estimate the water level dropped by several meters every single year. In what is a mere blink of an eye in geological time, perhaps only 1,000 years, an entire sea evaporated into thin air. What was left behind was a landscape from another world. A vast, hypersaline desert, thousands of feet deep, baked under a brutal sun. The air was thick with salt dust, and the only remaining water was trapped in toxic, super-concentrated brine pools that shimmered on the basin floor. Rivers that once fed a thriving sea now had nowhere to go but down. The Nile, finding itself at the edge of a colossal cliff, transformed into a gigantic waterfall. It began carving a canyon into the newly exposed seabed, a chasm so immense it would have dwarfed the Grand Canyon. This Dead Sea left behind a truly alien world. A vast, sun-scorched desert, thousands of feet below the level of the other oceans. The air, thick and heavy, pressed down on endless salt flats that shimmered with a heat no life could endure. It was a silent, desolate planet within our own. For decades, this incredible story was just a hypothesis, a geological ghost story. How could anyone prove such a cataclysmic event had ever occurred? The evidence, it turned out, was waiting patiently, buried deep beneath the seafloor of the modern Mediterranean. It just needed to be found. In 1970, the deep-sea drilling vessel known as the Glomar Challenger plunged its drill bit into the seabed. Scientists on board expected to pull up core samples showing millions of years of uninterrupted marine sediment. Instead, the drill brought up something that defied all expectation. A thick crystalline layer of pure rock salt, the undeniable proof. This discovery gave a name to the long-vanished catastrophe, the Messinian Salinity Crisis. With the gate to the Atlantic closed, the Mediterranean became a terminal basin. As the water evaporated under the intense sun, the remaining liquid transformed into a hypersaline brine, far saltier than any ocean on Earth today. The laws of chemistry took over. As the water volume shrank, it could no longer hold its dissolved minerals. They began to precipitate, falling like a slow, silent snow to the basin floor in a predictable sequence. First, the less soluble carbonates and sulfates formed a crust of gypsum. Then, as the very last pools of the ancient sea vanished into the hot, dry air, the most common salt, halite, came crashing out of the solution. It formed unimaginably vast deposits, some more than a mile thick. An entire sea solidified into a tomb of crystal, marking the planet's most dramatic desiccation. This wasn't just a local phenomenon. The crisis had ripple effects across the entire globe. When you remove 3.75 million cubic kilometers of water from the planet's oceans, The whole system feels it. The Earth itself was changed. The salt from all that evaporated water didn't just disappear. It was now trapped, locked away in one giant basin on the Earth's crust. This massive sequestration of minerals measurably lowered the salinity of all the world's oceans, altering the fundamental chemistry of the planet's lifeblood. For hundreds of thousands of years, this desolate salt pan defined the region. But the tectonic forces that close a door can also reopen it. The great African and Eurasian plates continued their slow, powerful dance. The land bridge at Gibraltar began to subside, slowly sinking back toward the sea. And then, a critical moment arrived. The rock dam, weakened by millennia of stress, could no longer hold back the full might of the Atlantic. A fracture appeared. A small trickle of water began to spill over the edge, carving a tiny channel into the rock, the first drop of an impending deluge. The geological evidence pointed to an ending, but it also hinted at a beginning of unimaginable violence. This is the story of the Zanclean Flood. The Atlantic, held back for millennia by a fragile rock dam at Gibraltar, finally found a weakness. A trickle became a stream, then a river, carving through the rock with relentless force. The initial channel did not just grow, it catastrophically failed. Water, moving with the power of 1,000 Niagara Falls, tore into the land bridge, widening and deepening the channel into a colossal gorge. The flow rate swelled to an estimated 100 million cubic meters per second. This was not a flood. It was an ocean being poured into an empty basin. This torrent was so powerful, it created a waterfall that eroded its own base backward at a speed of nearly half a kilometer per day. The sound would have been a continuous, world-shaking roar, audible for hundreds of miles. As the chasm at Gibraltar widened, the waterfall transformed into a set of immense rapids, a liquid conveyor belt of staggering scale, dumping the Atlantic into the Mediterranean abyss. The drying of the sea was a slow, creeping death over thousands of years. The refilling, however, was a geological instant. Current scientific models suggest that 90% of the Mediterranean basin refilled in a period lasting from just a few months to 2 years. A geological event of this magnitude happened faster than a forest could grow. Visualize what this means. The water level inside the basin would have risen by more than 10 meters every single day. Mountains that had stood in a dry desert for ages would see their bases submerged in hours, their slopes disappearing over the course of a week. It was a world being reborn in a torrent of water. This event, the Messinian Salinity Crisis, is now a cornerstone of geology. Yet crucial questions remain. Scientists still debate the finer details. Did the Mediterranean dry out completely just once, or did it undergo several cycles of drying and partial refilling before the final deluge? The evidence is buried, complex. And what was the precise trigger for the Zanclean Flood? Was it a gradual sea level rise in the Atlantic that finally overtopped the dam? Or was it a massive earthquake that fractured the rock, opening the fatal crack? The flood itself was so destructive it likely erased the very evidence that could give us a definitive answer. The Mediterranean Sea we know today, its deep blue waters, its unique ecology, its central role in human history, is the direct result of this epic cycle. Its existence is not a given. It is the product of a geological death and a catastrophic rebirth, an event that reset an entire ecosystem in the blink of a geological eye. This story, written in layers of salt and rock deep beneath the waves, is one of the planet's most profound lessons. It reveals a world capable of immense, sudden, and transformative change. It demonstrates that even the most permanent features of our world are temporary, subject to the raw, majestic power of geological forces that can erase a sea, and then create a new one. Today, the evidence of this colossal flood is carved into the seafloor. A massive submarine canyon, gouged out by the initial torrent, still marks the path of the Atlantic's return. This scar, hidden beneath the waves at the Strait of Gibraltar, is a permanent reminder of the day an ocean was reborn. It is a geological wound that tells a story of unimaginable power. Scientists uncovered this history not with shovels, but with sound. By sending seismic waves deep into the Earth's crust and listening to the echoes, they created a map of the world below the sea floor. This technique, called seismic reflection profiling, works like a planetary-scale ultrasound. It allows us to see layers of rock buried miles deep. The data that returned was astonishing. Below the mud and sediment of the Mediterranean floor lay a salt layer over a mile thick in some places, and cutting through the rock at Gibraltar was the unmistakable profile of a gigantic eroded channel. The smoking gun was found. The evidence was undeniable. This discovery fundamentally altered our understanding of Earth's processes. It proved that geological change isn't always slow and gradual, a process taking millions of years. Sometimes the planet operates in violent, catastrophic bursts. The refilling of the Mediterranean demonstrated that landscapes we see as permanent can be reshaped in a geological instant. The Zanclean Flood was also a biological reset button. The hypersaline basin was a sterile, lifeless desert, hostile to nearly all life. But as the Atlantic waters poured in, they carried with them fish, plankton, and countless marine organisms. The sea was repopulated. A new ecosystem was born from the waters of the old. But a profound question lingered. Could anything have possibly survived the Great Drying? In the scorching, salt-crusted abyss, was there any refuge for life? The answer lies in the existence of organisms that thrive where nothing else can. The extremophiles. These are microbes that have evolved to endure conditions of extreme temperature, pressure, or in this case, salinity. It is plausible that deep, briny pools, too salty to fully evaporate, harbored these tenacious life forms. They would have been the lone inhabitants of a dead sea, waiting for the return of the ocean. This entire event raises a startling question. Could it happen again? The tectonic plates that caused the crisis are still moving. The African plate continues its slow-motion collision with the Eurasian plate, relentlessly pushing northward. The Strait of Gibraltar is a direct result of this geologic pressure. The gate is not permanently open. In a few million years, the continued northward drift of Africa could once again seal the Mediterranean off from the Atlantic. The cycle of isolation, evaporation, and desiccation could repeat. The Great Sea is, geologically speaking, a temporary feature. The Messinian Salinity Crisis is a profound lesson in planetary impermanence. It shows us that oceans can vanish, deserts can become seas, and the world we know is just one frame in an epic geological film, where the forces of tectonics and climate are the true directors of the story.